All right. Mass percent of any element. Okay, we have to calculate mass percent of each element in some compound, whatever this stuff is, okay? It's right there. So mass percent equals mass of whatever element you're talking about over the mass of the compound, which is its molecular weight. That's the whole point of molecular weights, times 100%. Okay, so the first thing to do is find what is that. So molecular weight, which is a mass compound, there's all sorts of ways to say that, okay? So 8 times 12.01, that's how many carbons you have, plus 9 times 1.008, plus 2 times 16.00, plus 1 times 14.01. Okay, equals 151.2 grams per mole. So the mass percent of carbon equals mass carbon over a total. So it's 8 times 12.01 over 151.2 times 100% equals 63.54%. That's for carbon. Okay, you do that for each element. So mass percent H. So H was this one right here, right? Equals 9 times 1.008 over 151.2 times 100% equals 6.00% H. Let's put a C there just so our answers look good, okay? So mass percent O is right here, equals 2 times 16 over 151.2 times 100% equals 21.16% O. Now mass percent N we could either find by subtracting from 100, or we could just do this. Equals 1 times 14.01 over 151.2. But a check is to subtract it from 100. The other check is just add these all up. They should add up to 100. Okay, so that's number one. So you do the exact same thing here, so I won't explain it as much. So mass percent of each element in this. So I'll just do the math for you so you can see. So molecular weight of the thing, of the whole thing, equals 3 times 40.08 plus 2 times 30.97 plus 8 times 16.00 equals 310.2 grams per mole. So now we do each element in turn, okay? So for calcium, mass percent equals 3 times 40.08 over 310.2 times 100% equals, so for calcium, 38.76. Okay, for the next one, percent, what is it, P, phosphorus, equals 2 times 30.97 divided by 310.2 times 100%. So that one equals 19.97% phosphorus. And again, for oxygen, you could just subtract those two from 100, but 8 times 16 over 310.2 times 100% equals 41.26% O. So there's our answer for that problem. Okay, that's each element. All right, number 3. Now we just want iron, but we're going to look at the mass percent of iron in different compounds, and it's because just to show you that, you know, depending on the formula, it's going to have a different percentage in the composition. So for each of these, what we have to do, the molecular weight is find the molar mass. So iron is 55.85. And then oxygen 16. 159.7. So for percent iron equals 2 times 55.85, and then we're going to divide that by 159.7 times 100%. 69.94%. That's in the first one. And then in B, molecular weight equals 55.85 plus 16.00. There's only one of each. So that's 71.85. So our percent iron equals 55.85, because there's only one of them, over 71.85 times 100% equals 77.73%. This is actually how you can tell the difference between these compounds. You can analyze them for iron and determine a percent composition, and then you could say, well, it's not this one, it's not this one, whatever. C, so equals, we have 3 irons, 55.85, plus 4 oxygens, 231.6. So then percent iron equals 3 times 55.85 over 231.6 times 100% equals 72.34%. That is that problem. And I think that's the last one on this set. That's it.